Hi everyone! In this video, we will calculate the sample size required to estimate a population proportion. While on clinical rotations, a new physician aims to assess the clinic's patient readmission rates within 90% confidence. The physician wants the estimate to be within 8 percentage points of the population proportion. Use a graphing calculator to determine the sample size required to evaluate the clinic's readmission rates. To find the sample size, we need an equation. The equation is n, which stands for the number in the sample size, equals the z-value associated with alpha halves, quantity squared, times p prime, which is the estimated proportion of successes, times q prime, which is the estimated proportion of failures, over the margin of error, squared. Let's make a list of the items we need for the sample size. The first thing we need is the z for alpha halves, p prime, the estimated proportion of successes, and q prime, the estimated proportion of failures, and the margin of error. To find the z for alpha halves, let's look at the confidence that we have. A 90% confidence shows that it's in between two values of 90% between these. And so our alpha is the outside proportion, and so that's here and here. Because it all adds up to equal 1 or 100%, this means that the two together are alpha, which is 10%. So we need to divide this by 2 to get how much is under each of the tails for the outside of the confidence. So this is 0.05, and this is also 0.05. So if we want the z-score for right here, for all of the area to the left, we need to add our 90, 0.90, and 0.05. So the area or the probability underneath the curve to this point is 0.95. To find that z-value, we need to use our calculator and do inverse norm. But before we do that, let's find the rest of our items first. P prime is the estimated proportion of successes, and we weren't given that. And so we can't find the estimated proportion of failures either. So what we do is estimate those to give us the largest number when we multiply them together. That is a 50-50 chance. So we're going to make it 50-50 of 0.5 and 0.5. The margin of error was given to us in the problem, stating that the physician wants it to be within 8 percentage points. Changing that to a decimal gives us 0.08. The only thing we need now is the z-value, and then we can plug everything into our calculator. Let's go ahead and turn on our calculator to find the z-value. We need the inverse norm, so that's second vars for the distribution. And we'll go down to inverse norm, which is number 3. We can arrow down or we can press 3. Either will get us there. And then the area to the left that we talked about is 0.95. And then because we are standardizing this, our average is 0 and standard deviation is 1. We'll keep the tail to the left and then paste this into the home screen and press enter to run. This will give us our z-value for the area to the left of 0.95. Now, because our calculator will follow the order of operations, and this is all multiplication and then division, we can just enter it in from left to right. To prevent any typos, we can just square the answer by squaring the answer in the calculator, and then we can multiply this by our p prime, which is 0.5, and then multiply it to q prime, which is also 0.5, and then divide by the margin of error of 0.08, and this is squared as well. And we can press enter, and we get 105.685. Now we're dealing with people here, so we are going to round from 105 to the nearest whole number, rounding up to 106 people. Even if the decimal had been 0.1 or 0.2, we still round up to the nearest person. So our sample size should be 106 people, and now we're all done.